Tech Mag.
Do you know the correct way to throw a javelin and the mechanism that increases throwing distance? Competition javelins are made of metals such as duralumin or steel and are surprisingly light. Men's javelins weigh 800 grams and women's javelins weigh 600 grams. Athletes accelerate with a 30-meter run-up and throw 3 times. The longest distance thrown is recorded. The men's world record was once 104.8 meters set by Uwe Horn, but safety concerns led to rule changes. The centre of gravity was shifted forward by 4 centimeters to limit throws to under 100 meters. In the women's javelin throw, Haruka Kitaguchi, gold medalist at the Paris Olympics, continues to be a highly anticipated contender at the 2025 World Athletics Championships in Tokyo. Athletes are constantly working hard to throw the javelin further. Let's see what's needed to increase throwing distance. Compared to the iron ball used in the shot put, the javelin gains lift and greatly extends its flight in the latter half of the throw. The trick to increasing throwing distance is to make maximum use of lift, like the glide of a paper airplane. The time from run-up to landing on the right foot and releasing the javelin is about 0.4 seconds. Experiments using acceleration sensors have shown that the higher the maximum value of the acceleration curve, the longer the throwing distance. In other words, the key to increasing throwing distance is to efficiently transfer the kinetic energy of the run-up and the muscle energy used to throw to the javelin. The throwing distance of a javelin is also affected by the angle of the javelin at the time of release. If the angle is too wide or too narrow, the throwing distance will not increase. It is important to release it at the optimum angle, taking wind direction into account. A javelin with moderate flexibility is considered easier to throw, and one that minimizes bending vibration after being thrown will fly further. Motion sensors analyze bending and vibration. The MEMS motion sensor simulates the sense of motion in humans. Also used in drone posture and car navigation systems, this composite sensor combines an acceleration sensor and a gyro sensor. It consists of a resonator supported on a substrate, a comb-shaped movable electrode, and a fixed electrode. TDK's MEMS acceleration sensor detects changes in capacitance between electrodes due to deflection of the vibrator when acceleration is applied and calculates the acceleration. Motion sensors also play a crucial role in analysing athletes' biomechanics and tracking movements. Watch the games and experience the power of motion sensors in sports.